Zero. Thank you, everyone, for joining today's presentation. So I'm Mark Rouleau from the Social Sciences Department. I'm also an advisor in the Environmental and Energy Policy Program. I teach the Social Science Survey Methods course. It's actually being offered this coming spring. So if anything that I cover in today's discussion seems relevant or interesting to you, I strongly encourage you to follow up with a full semester-long course on a very brief introduction that I'm going to provide in today's talk. So I'm here to talk about survey design. Specifically, I can fill in some details on you for you so that you can get a better understanding of what it is that would be covered in the course and how we go about trying to diagnose the potential ways in which improper surveys can be designed. So I think that's the first thing to really get out of the way in any presentation about surveys, is that there's a lot of misconceptions about what a survey is. There's a lot of misconceptions about how to go about doing a survey. There's a lot of, let's call it, naive understandings of how to put a survey together. Surveys seem really easy to put together. It seems like all you have to do is slap some questions on a piece of paper and submit them to your respondents and hope for the best. But I'm often finding myself in the position of getting data from those types of survey projects in my office with the people who put those surveys together, asking me, why is my data not doing what it should be doing? Or why can't I do the things that I want to do with this data? And my response is typically, because you didn't think through the design of your survey before you conducted the survey. So it's very easy to rush forward and put a survey together, get some data. There's no problems with that whatsoever. That's the easiest thing you can do when it comes to surveys. Plus, there's the temptation that if you just slap together a survey and get some numbers from people, you can do some really interesting things with statistical analysis and analyze that data numerically and quantitatively and say some hopefully interesting things about the people that you studied. But today I'm going to talk to you about all the ways in which that can go wrong and you won't even realize it. So you'll be doing data analysis on data that's ultimately garbage in, garbage out. Right? The data is meaningless because it was improperly collected, and therefore no matter what you do with it in the analysis stage afterwards, statistically speaking, it'll work. But content-wise and substantively speaking, it's meaningless and worthless. It's not worth your time. So when I say survey, I specifically am talking about a very systematic way of collecting data from people. Why would you want to do a survey? Ultimately, it comes down to you want to be able to either describe this group of people well in an efficient way, or you also want to go even further than description. You also want to explain what makes them think and act the way that they do. So for the survey part, what is a survey? Just so you get some text down to capture ultimately what I'm talking about. The main purpose of surveys, or at least the ones that I'm talking about, not all of the different surveys you've ever seen in your life before, but the ones that I train people how to develop in my course, are surveys that are intended to produce a statistic or a set of statistics. So ultimately, these quantitative numerical descriptions that allow you to concisely summarize a certain aspect of a group of interest, of people, right? Or groups of people. The method itself also distinguishes what a survey is from what looks like a survey, but is not exactly what I talk about in my class and how to do the design. So for me, three things are critical in terms of the method. The main data collection approach is to ask people questions. They can respond in any way that's appropriate for the way in which you phrase the question, but ultimately you're going to take their response and turn it into a number somehow. You can get responses that are entirely qualitative in asking people questions. For example, what is your religion? Where did you grow up? You know, those types of things will give you qualitative responses from your survey questionnaire. But in order to do the analysis, you know that at the end of the day, you have to take those qualitative responses, turn them into a number to prepare them for your statistical tests. So ultimately, you go about getting those numbers by asking questions. Second, the main analysis technique, after you've turned those answers to those questions all into numbers, you've done the proper preparation to do that, you can use whatever statistical technique or test that is appropriate for your interest in terms of what you want to learn from that data. And I, just as a plug for another course that I teach, separate from the survey methods course, I also teach the social science statistics class. And I tend to encourage students to think about taking those classes as companion classes. So taking the survey methods class first, learning how to do the data development, how to get and extract numbers from people, and then take the social science statistics class where you can learn how to do the analysis and learn something interesting about those numbers that speaks to the people that you ask the questions from, right? And even beyond, right? Because the last point is really the beyond aspect. Ultimately, when you're doing surveys, the assumption is that there's way too many people you could ever talk to. You want to say something big and broad about a large group of people, but you don't have the time or the resources necessary to speak to every single one of those individuals. If you could actually do that, we don't call that a survey, not in the context of what I'm talking about. We call that a census. If you're in a position to be able to speak to every single member of your target population of interest, that's a census. You can do a lot of interesting things with census level data. Most of it is very descriptive. Considering the fact that you have talked to everyone, you aren't really making any guesses about what certain people in your target population are thinking or doing or acting like, because you've talked to all of them. So you can simply classify them based on the data that they've given you. It's rare that you're in that situation, though, when you're talking about large groups of people. So as a social scientist like myself, you're often in a position where you have to talk to just a fraction of those people. But you want to make sure you talk to the right fraction of people. So that puts you in a position to speak to a very few number of your target population, but be able to make large inferences beyond that small sample. So ultimately, that third point is the main analysis objective for the surveys that I help people to understand how to design is to infer from a sample to a larger population. Not to do a census. You could stop with the census by just getting numbers and doing the statistical analysis, but you're missing a major piece of the survey design aspect, which comes through inferring from samples. So I'll talk to you about both aspects, how to generate the right kinds of numbers and how to do so in a way that allows you to make these inferences to larger populations. That's critical to survey design, both.
I have a question.
You said you have lots of questions.
Yes,
so
there's quantitative, my brain is confused. So I saw on internet, I was reading, that now there is something called like big data, this concept of big data, right? When it's collected for large numbers in real time.
Sure.
So they come up with numbers, of course, statistics, but I'm wondering if that could be considered a survey too, because there is real time, they get numbers that do analyze it with that, but it's really, really big, right? Yeah,
so it's not a question that I could say a direct yes or no to. I mean, honestly, the answer to that question is it depends. It depends on how exactly that data was collected, because it can be collected in many different ways under many different circumstances. Usually when people talk about big data, they're talking about massive amounts of data that are way beyond what we would ever be able to collect in the context of a survey. The sample size sort of golden target objective is usually in the order of maybe 1,000 at most. Big data, we're talking tens of thousands, if not millions of data points.
Okay.
And what puts people in a position to be able to do the big data analysis techniques that we can't really do with surveys is that in most cases, when it comes to big data, people are voluntarily giving this information. Right? You may not even be aware that you're volunteering this information, but every time you do something on Facebook or on Twitter, that stuff is getting captured. And unless you go through their privacy policy and specifically uncheck the box for for this data to be collected by those organizations. That data is going to be collected, and there's going to be a lot of it, tons of it. And the people who seem most interested in analyzing that kind of data are the people who see a practical value in learning something about your interests that translates into maybe some sort of marketable product. So what they really ultimately want to do, I'm not saying for all people who do big data analysis projects, but for the people who take that data from places like Facebook or Twitter, they're really interested in, or Amazon. I mean, you're already revealing your purchase preferences by making purchases or even hovering over the link of what you might be interested in the future. So they want to take that information and turn it into a way of packaging a product that's most likely to be appealing to you. And what they care about at the end of the day is if you make that purchase or if you don't. So that's ultimately what they're trying to explain. But in the context of doing surveys, obviously we're not selling a product. I mean, there are businesses that do surveys as well, but from a social sciences perspective, we don't want to know what makes them buy things or what they want to hear. We want to know the reality of who they are, right? We want to know the unfiltered truth about how they think, how they behave, and why they do the things that they do. So we don't care if we can get them to do a certain thing necessarily. We want them to reveal in a way that is as truthful as possible what is actually going on in their head. Right? And then with that information, we can look for, using the statistical analysis techniques, some possible relationships between variables, between what people think and how they act, to try to explain things like their behavior. And maybe that puts us in a position as a policymaker, because coming from an environmental and energy policy program, where then you have an opportunity to do some manipulation and say, if people are acting in ways that are harmful to the environment, let's say, and we know what causes them to do that, their attitudes towards a certain thing, if we could manipulate that aspect of their thinking, maybe we could get the kinds of behavior that we would want that would be better for the environment, as an example. So you could take it to that level, but there are so many layers before you ever get there that you're really interested in just understanding the unfiltered truth. And that's why you really need to not just get at the information that people are willing to volunteer and sort of guess why that matters, but you really want to know specific things about those people.
Yeah.
And that's when you go for the survey, because big data has a lot of great information out there, but if you look at what's available based on what people are volunteering, you're going to see it's very limited. So oftentimes you opt for the survey because you have a very specific objective, and the available data that's out there doesn't fit that objective. So you tailor your own design to creating the data you need to do the analysis you ultimately want to accomplish at the end of the day. And on top of that, I would say, I'm not here to sell you on any particular method. Just because I know how to do survey design doesn't mean everybody should do surveys. They shouldn't. In fact, the first thing I say in the survey methods class is there is no need to do a survey if the data is already out there. If the data is already there, don't waste your time, because it's a lot of effort and you can get it wrong in many different ways. So don't do it. It's not worth it. But if you find that what you really want to explain about the world, about people, is something where data simply doesn't exist in the first place, then you are in a position where you have to go out and collect that data. You have to create that data because it's not there. But most people have extreme practical limitations about what they can and can't do in terms of collecting that data. So you're going to find that most of what you end up doing in the survey design process is, how do I do this as best as I can without making as many mistakes possible? So oftentimes what you end up doing is opting for a less than perfect solution, but making that less than perfect solution as close to perfect as it can be, realistically speaking. Okay, so let's move on to the next half of the question that I posed to you. So I hope you have a better understanding of now what a survey is. So when I say survey, those three things come to mind in particular. Why would you ever want to do one? I think since you already prompted me with that question before I got to this part of the slide, I think I've already answered that. It's because the data is not out there. Right? You want to learn something about people, and you need a specific type of data in order to do that, and that data doesn't already exist. Right? So it puts you in the position of, how do I create that data? How do I do it well? So usually there's two reasons for wanting to do this. The first you can say is somewhat simple, but you might not realize how challenging it actually is until you try to do it yourself. So the first reason is to create the data that puts you in a position to efficiently describe the characteristics of a particular group. And just to give you some practical examples, this is happening all the time, and it requires extensive resources to do. The unemployment rate, it's just a number. It's just one number. But to create that one number well, accurately and reliably, so much effort has to go into speaking to samples of people in businesses and other organizations that hire. And there's also a lot of controversy about what that number actually represents, because we've made some very specific decisions about what counts in terms of being unemployed versus not. So for example, in the United States, you're not considered unemployed unless you're actively seeking work. If you've stopped seeking work, you don't go into this number. That's a conscious decision that was made on behalf of the government officials at the Bureau of Labor and Statistics, because they felt at the time that the unemployment rate would be a more accurate reflection of those actually pursuing jobs in the job market, and they didn't care about the people who didn't have an interest in getting a job, because the assumption was that they wouldn't want to get hired anyway. But in job markets like the one we're experiencing, trying to pull out of a major global recession, this actually happens more often than it did when the Bureau of Labor and Statistics decided on measuring the unemployment rate that way. Because now you have people who are simply exhausted from seeking a job, who no longer have the effort in trying to do so. And so they've fallen back on what is not their best option, but it's an option that they see as more realistic for them now. That's one number. And the only task involved in doing the survey to create that number was an extremely simple task, which was a descriptive task. You simply wanted to describe a population, right, with a single number. There's other examples that I'm sure you're familiar with. The public opinion surveys that's happening all the time. So you know what President Trump's approval rating is, and as it adjusts over time. You know what every politician's approval rating is. And if you don't know what it is, they certainly know what it is, because they know it's a pretty reasonable reflection of whether or not they need to make a change in terms of their policy stances, because it is critical to their survival as a politician. So either they listen to those numbers, or they potentially open themselves up to the risk of being voted out of office. So you're familiar with those. I'm sure you maybe haven't been involved in any of those two surveys as a survey taker, but you probably have been involved in these kinds of surveys yourself. So you've been on the receiving end of the survey for customer satisfaction surveys, and probably many, many, many other junk surveys. And let me just put this out there, that if this is your only exposure to how people collect numbers from other people in this world, you have a very, very poor understanding of what we're trying to do when it comes to survey design. These customer satisfaction surveys are almost always horribly designed, and they do not in any way incorporate many of the principles that we need to think strongly about when we're trying to do social science related data collection. And in fact, you can sort of ask yourself if they really even do care about the numbers at the end of the day, or if it's just a feel-good thing to let customers know they're listening to you, but aren't necessarily responsive to whatever messages they get, because the numbers are garbled to begin with, given the lack of effort put into collecting that data. So do not hold an entire method of data collection accountable for the worst suspects in exposing you to the worst way of doing these things. If this is the only exposure you have to survey design, pretend that that doesn't happen, because this is not actually survey design, not from my perspective. And not to get too personal when it comes to surveys on this campus, but you've seen surveys on this campus. You have been pestered with a lot of different surveys on this campus that are also poorly designed. I won't name names, but I will tell you the percentage is quite high that when you get a survey, it's highly likely that it was not vetted with the proper survey design techniques that it should have been vetted with. What should you do in those situations? Probably don't take that survey. But when you see a good survey that comes through, that you know has the proper approach to doing survey design, please take those surveys, because those people have really put the effort in to making sure that they collect the right data for the right reasons. And they really, really, myself included, rely on you for that data. They can't do their work without you. Think of how dependent they are on you. You have no interest, maybe, in their research, but they have an extreme interest in your response, because without it, we can't do anything. So it's a very risky place to be in as a researcher if you rely on other people to give you the data that you need, who already, because of these kinds of things and other junk surveys, have an extremely low motivation for participating. So part of what I try to convince my students to do is go around explaining to people that there is a difference between a junk survey and a good survey. And you should commit your time to doing good surveys, and you should absolutely ignore the junk ones. But don't hold everyone accountable for the bad behavior of the worst of that group. Okay, so that's your reason number one for why you would want to do the survey, simply for descriptive purposes, but things get even more complicated than that, especially if you're collecting more than one statistic. So if you have more than one statistic, now you can look at relationships between variables. Bivariate, two variables, or multivariate, many different variables, and their impact on a single variable. So I think most of the social sciences want to take it beyond just the descriptive stage in their own research, my research included. So reason number two for us in particular is to try to figure out why people think and behave the way that they do. And as I already said earlier, I'm always thinking ahead to the next step as a policymaker, from a policymaker's perspective. If we can figure this out, maybe we have some clues to influence your behavior. Some would say manipulate, but I'll say influence your behavior in a positive direction, right? If we really know how this works. But there's no way you can really know how this works with junk data. So we have to be very conscious of what it takes to produce good quality survey data. That's what survey design is all about. So the big reveal, what is the best way to design a survey? There you go. There is no best way. There is no best way to design a survey. In fact, it all depends. It all depends on the context. In fact, no survey will ever be perfect, because considering the fact that you're doing a survey because you can't talk to everyone in the population, by definition, it will be imperfect. So you try to minimize the imperfection of that survey as much as possible. So a better question you should be asking yourself would be, what are all the ways I can go wrong in designing a survey? Be conscious of that as you do the survey design. And once you're very conscious of all the ways you can go wrong, at that point in your development of understanding how to do surveys, many people feel extremely frustrated, throw up their hands and say, I can never do this. It's too hard. It is. Because beyond that point, everything you do will be a sacrifice. You'll be making sacrifices in every possible area you could. The ultimate goal, though, is to make the best sacrifices in the best way. So you minimize ultimately what you want to minimize in terms of making bad surveys, total survey error. So survey design, how to do the proper survey design, is not based on a template of do this, then that, then that, then that. It's based on error avoidance technique. So there are so many different ways to design surveys, good surveys and bad surveys. The only thing you really need to be conscious of is the ways that those things can result in error. So when you make certain sacrifices, you need to know how much error is this going to introduce in terms of the total survey design error versus making another sacrifice that I could have made as an alternative. Make the decision that gets you the least total survey error. So where are these sources of error? They're all here. These are all of the sources of total survey error. And in fact, when I do the semester-long version of the survey design course, each box that you see on here, with the exception of what is your ultimate goal, each box that you see on here, we dedicate at least an entire week to discussing all of the ways that the error can be introduced in each of these stages of survey design and the techniques that you need to consider in terms of minimizing that error. So this is, I guess, a graphic description of my survey method syllabus right here. This is the syllabus as a picture. So keep in mind, your ultimate goal is here. You want to be able to produce a survey statistic. You need to consider two things when you're doing this. On the left-hand side, all of these boxes, these 4 boxes, have to do with what we call measurement error. So these are the ways in which the single piece of data from a single respondent can go wrong. Right? From developing the construct, what it is that you want to measure, down to the response and editing that response before it actually goes into the spreadsheet of numbers that you'll analyze with your statistics. The other side is the representation side. If we were doing a census, we would ignore this side. All we would care about in a census is making sure that those individual measurements from each respondent are captured well. But since we can't do a census in most cases and we're doing a survey as an alternative, we also have to consider this other major source of error. So that's the representation error. Starting with identifying who your target population is, who at the end of the day you ultimately want to make inferences to, through getting information from those people, identifying who they are as a sample, getting their actual information when they respond to your survey, and adjusting whatever numbers that they give you so that you can do your analysis appropriately. Combine those two things together, and you get your survey statistic. For just one column, let's say, in a spreadsheet. If you want more than one variable, because you want to do more than just description, you want to explain, you need at least another column, and you have to repeat this again. I can walk you through this in a little bit more detail. I'll start with the representation side first, just to kind of give you a preview of the things you'd be thinking about and why it matters when it comes to survey error. And then after I go through each of these boxes, then I'll just open it up to questions. And if you have anything specific you want to know more about it from any of these boxes, let me know, or I'll encourage you to take my survey methods course and you can really learn more about that in a full semester. So starting with the target population, what do I mean when I'm talking about a target population? This would be the group you ultimately want to be able to describe or explain. And this is something that is entirely up to you. You get to decide this. And the best way of thinking about how to make that decision is to assume that there were no practical limitations to doing your study. None whatsoever. You had all the money in the world. You had all the time in the world. And it was extremely easy for you to talk to everyone in your target population of interest. If that were true, what bounds would you put on the group that you're trying to study? Who's in that group and who's not in that group? That's the only thing we need to consider at this stage. There's nothing numeric going on here. It's completely qualitative. Who, at the end of the day, do you ultimately want to be able to say something about? As a group, not as an individual. So, examples of target populations. Anytime a survey is sent out through the campus mail, one possible target population would be the entire campus. Any person who works or goes to school on this campus. That isn't the only possible target population, right? We have many subgroups in this campus. We have staff, we have faculty, we have tenured and untenured faculty, we have adjuncts, we have graduate students, we have undergraduate students, and many other groups that I haven't even named. So it's easy to assume that your target population is just everyone in the general vicinity that is the focus of your study. But what you really need to think carefully about at this stage, which is a very, very qualitative decision, is that the appropriate group you want to be able to say something about at the end of the day? And you might find that when you set your target population to be too large at this very early planning stage, once you start getting down through these steps and going down this branch, that was just a fantasy. It's impractical to be able to collect all that data from all those people and do it well. So here at this stage, I encourage my students or anyone who's doing the survey to think big. Be totally unconcerned with the practical limitations of doing the study, because you can always bound your scope and make it more narrow once you realize why that's necessary. But the bigger the better you think at this stage, it's going to be beneficial to you. So target population is the first thing that you try to get a sense of in terms of who you want to be able to explain. But when you make the step from that first box to the second, that's when the practical limitations start to really hit you. So in moving from your decision of a target population to a sampling frame, which is critical for you to actually draw a sample of people, that fraction of people from your target population, who you will actually get information from, that will put you in the position to say something or infer to that larger target population. That can only happen well if you have a good sample frame. What's a sample frame? Just a list. Just a list. A great sample frame is a list that includes everyone in your target population. But great sample frames rarely exist. In fact, this is one of the first areas that most people struggle, because when they realize that their ambitions were quite large in defining their target population, and they go to find that list of everybody, and it's not out there, you go back to your target population and say, no, I have to redefine that, because I only have a list of these people, not those people. So it'd be great if I could say something about everyone, but my list doesn't permit me to do that. What's even more challenging, which people are often in the position of having to do, which is never really satisfying, is you have no list at all. None. What do you do to develop a sample frame when you don't actually have a list of people from your target population? Not even a single name. So we talk in the survey methods class about different alternative strategies you can use for developing sample frames when lists do not exist. One example would be using a map. Right? If you have a map and your unit of analysis is a household, let's say, and each household is visible, technically you have a list. It's a picture. But as long as every household unit is visible in that picture, that's a list. You process that list a little bit differently than you would the lists like laundry lists that you're normally used to. But there's no reason why it can't be considered a list. It certainly is considered a sample frame, because it puts you in a position to be able to select with a known probability, and for every possible unit in your sample frame, that probability must be greater than 0. Everybody has to have a chance of being selected from your sample frame to get you between that list of everyone to your sample, which is only the people you'll be getting information from. So you either do that with a list, or you can do that with a map, or there's other strategies that you can use when you're in that uncomfortable position of not having a list. To summarize what I'm saying here, ultimately what you're trying to do when it comes to total survey error is you're trying to minimize what we call coverage error as much as possible. Coverage error occurs whenever your sample frame is missing elements from your target population. If they're missing, they could never be sampled. But if they're members of your target population, that's problematic. It's extremely problematic if they're missing for a reason that correlates with what you're really trying to measure. So coverage error is what we call that, and that's the stage between going from a target population to a sample frame to put you in the position to do the sampling. So once you have that list, or you have a substitute for the list, the best thing to do is to randomly select randomly select elements off of that list to construct your sample. There's a lot of different ways you could go about doing this, which we spend at least a week, if not 2 weeks, discussing in the semester. But the simplest way to get a sense of what's going on here is to think of the easiest thing you could do. If you had a list of everyone in your target population, you had a sample frame that had 0 coverage error, all you need to do is calculate what the appropriate sample size would be, which, by the way, there are formulas for. Or, which is more likely to happen in social science research when you have limited resources, you go with the sample size that's as large as you can make your resources accommodate. So the ideal sample size is something that you may not be able to achieve because of your lack of resources. But when it is possible to achieve that ideal sample size, you use the simple formula for calculating the proper sample size and randomly select individuals based on simple random sampling from your list. A simple computer can do this. You give a computer a list and say select 1,214 elements from this list. Any computer can do that. What's critical about that process, though, is that it is random selection. Random selection is critical to make sure that there is no potential for a correlation between somebody getting selected on that list and the survey statistic that you're ultimately trying to capture. Or, probably even worse, somebody not being selected from this list correlating with the survey statistic that you want to capture. So what we're ultimately trying to control for here is the sampling error. And we want to keep that to a minimum as much as possible. And sometimes that's quite challenging, especially when you have practical limitations to being able to construct large samples. You simply don't have the time or resources to talk to that many people or get information from them in whatever mode you use. But once you do have your sample, the next step then is to go and actually get the information from those people. Because at the moment, they're just a sample, they're just a subset of the larger target population that is sitting on your desk with names and contact information, waiting to be contacted. But it's not until you actually reach out to them and try to get their information that they become a potential respondent. So in moving from the sample to the respondents, now you're actually making the step of doing some sort of recruitment. Recruitment can happen in many different ways. If you're doing a telephone-based survey, it could be just a matter of making a phone call, trying to identify the relevant respondent and trying to convince them to participate in your survey. If you're doing a self-administered written questionnaire, it could be a mailing procedure. Usually there's a number of tips involved in how to increase response rates, which we discuss in great detail when we're discussing this aspect of the semester. But how to encourage people to participate when you're not there to speak to them directly. Do you incentivize them? Do you give them some money? It turns out that that's helpful, surprise, surprise, but harmful, which also may be a surprise. If you incentivize too much, you get the wrong kind of people taking your survey. But if you don't incentivize at all, you don't get enough people to take your survey. So usually there's a happy medium, and the happy medium seems to be somewhere around $1, $2, never more than $10. It's shocking how little an incentive can get you the right kind of respondents. And if you go too far, that's when you start getting the wrong kind of respondents. So most of those techniques we discuss in reducing your response rate so that when you move from trying to recruit people from your sample to actually being respondents in your survey, you can get as many of these people into your survey as possible for the right kinds of reasons and not introducing bias in that way. So what you're controlling for there would be the non-response error. You want to make sure that there is no correlation between the people who decided to participate in your survey and the survey statistic, as well as the people who decided not to. Because you'll never speak to the non-respondents. You'll never get a chance to get any information from them. I shouldn't say any. There are some good strategies for following up with non-respondents to at least get some minimal amounts of information to know how bad this is, to be able to estimate your non-response error. Sometimes non-respondents might be willing to answer a very small questionnaire. they won't commit to answering all the questions in your questionnaire, but they'll answer a few. And by being able to answer a few questions, you get some clues about the possibility of this correlating with this. And then once you actually do get your respondents recruited into your survey, that's when you give them the survey. It can be a written questionnaire, could be self-administered, it could be an interview-based survey, it could be a survey that's done over the phone. There's definitely a tendency towards online surveys whenever possible nowadays, and there's pros and cons to doing that. The big pro to doing that is it's easy. It's nearly cost-free. But the big disadvantage to doing that is because it's so easy, you get so overwhelmed as respondents or potential respondents with those kinds of surveys, you're less likely to see a motivation in doing those surveys. So what you have to do is you have to trade off in making your decision about how to get the information from your respondents. The proper choice of a survey mode is what we call this. Trade that off in terms of the practical limitations of collecting that data with the possibility of introducing non-response error by using the wrong mode. Some modes are much better at boosting response rates than others, but then those modes are also more expensive and more taxing on your resources. So you're trying to do that trade-off. It's the kind of sacrifice you make all the time in doing survey design. Once you get the information from your respondents, sometimes it's not always in the form that you need it in order to do the analysis. People aren't computers. So people don't often feel comfortable or it's not appropriate to extract the information from them in a way that translates directly into a number. So oftentimes you get the respondents to give you answers in a way that's natural to them, increases their likelihood of responding and responding accurately. But then when you go back to the lab, once you've collected your data, you find that it's necessary to do some post-survey adjustments that would allow you to translate those answers into more accessible numbers that can be analyzed with statistics. And a little twist to the things that you can try to do to maybe minimize some of the problems that would have crept in here. Oftentimes you'll find that even though you've gotten respondents into your survey, they don't answer all your questions. They'll answer some of your questions, but they won't answer all of your questions. So some of the post-survey adjustment techniques would also involve more complicated things like imputation, where you're trying to impute what the missing value would be based on the answers that they provided to the rest of your questions. And there's other complicated weighting procedures that you need to factor in if you've done some more complicated sampling techniques. So proportion-based sampling would require you to adjust the weights of your respondents relative to the proportion in which they were participating in your survey based on the group sizes. So that's what's going on in the post-survey adjustment stage. What you're trying to be careful of with respect to representation error is that you don't alter those respondents, thinking things like imputation or post-survey weighting. You don't alter those responses in a way that then creates misrepresentation with respect to the group you're trying to describe. So that's your adjustment error that you need to pay attention to. And that is basically a summary of this right-hand side when it comes to representation. So all the ways you could go wrong when it comes to misrepresenting the data based on your sample include coverage error, sampling error, non-response error, and adjustment error. And the complicated thing is that some of these things influence the others, and some of the decisions you make about minimizing certain aspects have impacts on the others. The other side, only 4 boxes on this side. We have something similar going on the other side, but this branch is talking about measurement error. So you can think of this not from the perspective of the group as a whole, are you well representing the group, but are you actually extracting valid and accurate information? And this is a single cell for each respondent in your Excel spreadsheet, let's say. So you start with the construct. This is, again, like the target population. It's quite abstract. At this stage, you're really trying to conceptualize what it is that you want to be able to capture from your respondents, every respondent. Surveys are systematic, so you will capture the same information from every single respondent in a structured way. If you can't do this, you're going to introduce even more error. So what is the one piece of information that you ultimately want to extract from your respondents that's going to give you this survey statistic? At this early stage, you're conceptualizing and you sort of give it qualitative names. So we can call it the unemployment rate if we want to. That is what we would put here. And then once we realize that we have to go around and actually measure this and capture it in terms of numbers, we realize we have to do more than just come up with words for this concept. We have to figure out how to translate those words into numbers. So we have to move from the concept itself to the numbers through the process of operationalization. So what's going on between the construct and the measurement is the construct is the abstract concept itself, what you hope to capture, which you can describe in words, versus what you actually measure, which is, in many cases in a questionnaire, the specific question that was asked that elicits a specific response from your respondent. So in moving from the construct to measurement, what you're thinking about here in particular is how do I ask the right kind of question to really capture abstractly what I'm talking about here. Sometimes this is easy. Sometimes it seems easy, but it's a lot harder than you think it would be. But most cases, it's extremely challenging because in most cases, especially when it comes to social sciences, the concept that you're trying to capture at the end of the day, measuring in terms of a survey statistic, is quite complex. So to give you an example, one possible construct of interest that many people seem to want to include in nearly all surveys would be a measure of someone's wealth, let's say. We'll start very abstractly. So we're very interested in people's wealth because we feel that wealth has a strong influence on the way people think and the way people behave, or maybe it's vice versa. And so there's something about wealth that really interests us. But at the stage of conceptualization, wealth is a reasonable construct to put into this box. But when it comes to extracting wealth information from respondents, you have to come up with a reasonable question that's going to tap into the information that you really want with respect to wealth. So an easy thing to do in coming up with a question on a questionnaire would be to just take that concept and turn it into a question instead of a statement. I want to learn something about a respondent's wealth. Therefore, the question is, what is your wealth? Right? The question has to be posed to the respondent because it's the respondent's wealth you want to learn something about. So what is your wealth? Might seem like a reasonable way of turning that construct into an actual measure in the process of operationalization. But what if I asked you that question right now? Would you even know how to respond to that question? If I said, what is your wealth?
Poor.
You might say poor. You might say a specific number. Right? I won't put any specific number on it because that can be sensitive, right? But you have to figure out how you want to get that information from your respondent. So not only do you have to think through what you ask, but the position you put your respondents in providing an answer. Do you leave it blank? Do you leave it open-ended? They can give you any possible response. You do that, you get poor, you get 147,000, right? And you get, why are you asking this question? And then when it comes to, from the respondent's perspective, what are you actually thinking when you see a question like this? What comes to your mind? There are many different ways of measuring wealth. Are you thinking about your annual income? Did you include the gambling earnings that you made last week? Because we all know you did, even though the IRS isn't going to see that, right? Do you think about the stocks you have in your investment portfolio? Do you include the value of your home, even though you owe most of it to the bank, right? There's many, many different ways of tapping into that very abstract construct. So what you really need to think hard about is, what is it that I actually want to know? And ask a very specific question, as specific as possible, to make sure that the respondent knows exactly how to give you that information. If you keep it open-ended, you will get different responses from different people. They might give you a qualitative answer or a numeric answer, or they might just be thinking of different things at the time that you ask them. If you're not thinking about the value of your home, but you are, I can't compare those two answers. I have not extracted that information in a systematic way. As a researcher, I need to ensure I've designed my survey and the question in that survey to be consistently answered by every respondent. We want to minimize inconsistencies as much as possible in moving from the construct to the measurement. So that's your first practical limitation that comes in when you're doing survey design on the measurement side. So what you're trying to do there is, it should say construct error, sorry. It should not say coverage error. This should be construct error. You're trying to minimize construct error. And this is really just a matter of your own personal interest as a researcher. You say you want to extract this kind of information. To what extent do you think that asking this question in that particular way really does get you that information? If there's a difference between what you asked and what you were hoping to get information on, you've introduced some construct error in the process. Sorry, that should say construct error. And then you have to go out and get the information and actually extract it from your respondents. So you give your questionnaire, or you do an interview, or you do something over the phone, and for every single question that you have in the questionnaire, you get a measurement back. Right? You get a response back from each of those individuals. And so the stage between measurement and response is where the measurement error can creep in. And it can creep in for many, many different reasons. The most important reason would be that the respondent just misunderstands what you're asking. And it's really unfortunate if this happens from a researcher's perspective, because you often have no way of knowing. You get whatever information the respondent gave you. And so what you really have to be cautious of is you think the question that you asked and phrasing it the way you phrased it will get you the information that you want because you designed that question. So every time you read that question and think about the possible answer options, the answers make sense to you. And they seem like they would be consistently responded to by each of your respondents. But you often have a very biased understanding of how you read your own writing, right? If you're working on theses and dissertations, you know exactly what I'm talking about, because this is what your advisor is talking about. So it's hard for you to perceive how other people might misinterpret the phrasing of that question and give you the wrong information. And keep in mind, they're not doing this to be deceptive or devious in any way. We are assuming at this stage that they're absolutely trying to give you the information that they want. The problem is the breakdown in interpreting what you're asking. They simply just don't understand how to give you that information or what exactly it is that you're looking for. So that's when measurement error is going to creep in, and moving between the question that's on the page and the thought process between processing that question and having the respondent do something, either verbally or in writing, to give you that response. That's when the measurement error is going to creep in. Oftentimes it's happening in the respondent's head without you knowing it well. But there are techniques you can use to anticipate the ways in which those things go wrong. For example, you have other people read your writing. You don't just write to yourself and assume it's perfect. You know now it's not, right? So you write and you have other people read it and you have other people provide feedback. And so this is the process where we call, in survey design, the pre-testing stage. Right? So oftentimes you want to do a number of different things to pre-test your survey questionnaire to make sure that you have at least a reasonable attempt at extracting the correct information that you want to get. Pre-testing can come in many different forms. For example, you could do a cognitive interview with a respondent, sorry, not an actual respondent, but somebody who is a part of your target population who could potentially be a respondent. What you do with that individual is you sit them down. If it's, let's say, a written questionnaire, you have them complete the questionnaire and you tell them, I'm not at this point interested in what answers you actually give me. I'm more interested in the thought process that took you to that answer. So it's a think out loud. They are constantly vocalizing what they're thinking as they're reading through your questionnaire. And that will allow you to spot things you would have never realized because it all made sense to you in your head when you put it together. You can also do other pilot tests where you sort of give a very small sample, a practice questionnaire where they give you responses. You can do some initial analysis to see if those responses are making sense. make some tweaks to the questionnaire before you send it out to the larger sample that you actually want the information from, and anything really in between. If you're doing interview-based surveys and you're going to do more than one interviewer, this is also a great time to test out inconsistencies that different interviewers might introduce into the measurement process. Because in that case, it's not the respondent themselves that's reading the question straight from the paper, taking that information and giving you an answer. All of that information is being filtered through another person. And you've played the game of telephone before, so you know that not everybody passes on information accurately from one person to the next. Anytime an inconsistency creeps in how an interviewer is interpreting a question or an appropriate response, or probing for more information, or trying to help the respondent clarify aspects of the question, all of those can also introduce measurement error. So pre-testing can be a good opportunity for you to do some training with the multiple interviewers that might be doing the work for you, so they can be consistent in answering and probing for answers. Asking questions and probing for answers. And our last step here, then moving from getting the actual response, again, there might be a number of situations where for each individual, it might be necessary to edit that response so it's appropriate for analysis. And in this case, I think I misspoke over here when we're talking about representation. This is where the weighting is going to be really critical. In the edited response, this is where things like imputation and filling in missing values for the individual respondents will be appropriate. So what you're trying to minimize here and moving from the response to the edited response is the processing error. This is what you will introduce by manipulating your data to get it ready for data analysis. When you've done all of these things, you will end up with a survey statistic for each respondent. If you repeat this process for all of the variables that you want, going through this stage as many times as you have variables, you'll end up with a set of survey statistics. It's going to look like a spreadsheet where every column represents a variable, every row represents a respondent or a case, and the individual cells are the specific statistic that particular respondent has given you for that particular variable, and you have an entire spreadsheet of data, and I'm done. That's all I had.
Yes,
Oh, really?
It does this. It presses and then it wakes up.
Wow, okay.
So you were actually done?
Yeah, that was perfect timing. So all I was going to say at this point is that puts you in the position to do the statistical analysis that I think maybe many of you already know how to do. But if you go around doing statistical analysis with bad data, don't do it at all. Just don't do it. If you don't even know if your data is good or bad, come and talk to me. I'll tell you. But if you ever want to be in a position where you can collect your own data and know it's done well, consider taking my class, and we can talk about these things in more detail so you know how to do those kinds of assessments. Thanks for listening, but I'm happy to answer any questions you have.
Yeah, it's open for questions.
So it's always very hard, as you said, how to translate or create from a concept, right? In social science, something you can actually measure.
Yeah.
Sometimes when it's like very specific, and you classify, for instance, what's your religion? You can be Christian and Hindu and Muslim.
Yeah.
But even there are some variations, right?
Sure.
That maybe if you say, okay, I'm gonna translate Christian to 1 and Muslim to 2, and
yeah.
but you will not gonna capture those variation. For instance, within Christian, there is Catholics, and there is how do you deal with? You know what I'm trying to say?
I do know exactly what you're trying to say. So I don't just teach survey methods and statistical analysis. I teach research design as well. And so everything I said about designing a proper survey and having to make sacrifices is true for research design decisions in general, right? So you're constantly having to make sacrifices. In the social sciences, the sacrifices you make would be precision and quantity over maybe less precision, but higher quality and depth of information. And usually that's when people opt in the social sciences for quantitative survey-based studies versus qualitative interview-based studies where you're only talking with a small number of people. When you talk with a small number of people, you know, I was saying with the surveys, you're shooting for about 1,000. Sometimes that can go down as low as 100. You start going below 100 and people start to question what you can really infer from that data. That's not the kind of limitation that people who do qualitative analysis feel like they're up against. The limitation that they're up against is really trying to make sure that they get broad descriptions as broadly applicable to the population that they're interested in, because they don't ever plan on inferring from the small number of people they ultimately talk to. They just want rich descriptions. And so what you're saying about how to go about measuring religion can be done in many different ways using many different research designs. In the context of surveys in particular, it all depends on what you want to be able to say with that statistic. If measuring in fine detail the specific sects a person can be in, not just the religion itself, the broad-based category, but the sect within that religion matters to you because you want to just describe the number of people that are in each sect. Or you want to know if you're in this sect, but not just this religious category, does it influence the way you think or act? Then there's no reason why you can't design the question itself to be more specific. But you do have to be conscious that you can only ask a limited set of questions.
Right.
So you can't continue to probe for more and more and more information like you could if you were doing smaller N interview-based studies, qualitative studies. So you better get it right, and you're not going to have many opportunities to get it right, so get it right the first time. Yeah.
I have a question. So like when this, I want to start from the analysis, like when people do statistical analysis, for example, when they have an outlier,
Yeah.
they usually remove it because they say it's skewing the result or something like that. But is that introduced because of a sampling error or something like that? Because even if it's an outlier, it's saying something about the data, but usually, from my experience, it's removed from your analysis or data or something. And is that because they assume it's a sample error or something, or is there any relationship to that?
It's not necessarily assumed to be a sample error. One of the reasons why you can get an outlier is because you have measurement error. So there's some processing error between what you were actually asking and the information that they actually gave you. And so people could have just made a mistake. When you ask them for income, they meant to put down $100,000, but they actually accidentally added like 5 more zeros. They didn't mean to do it. It was a mistake in them giving you the information. And that's easy to check because you could do a reality check or sanity check on your data by going to that outlier and saying, does that number even make sense? Did I even ask for that kind of information? Or does that seem beyond the realm of possible, you know, based on the information I wanted to give? If you see that people are giving you information that clearly was a mistake, then it's perfectly acceptable to just remove that outlier from your data set. But if you go to that specific point in your data set and you realize, no, that does seem like valid information, then it's not as easy to say, well, let's just drop it. I mean, the tendency to want to drop it is to make your models fit a little bit better. But if you're not a statistician who only cares about good fitting models, if you're a social scientist who really wants to learn about your population well, you don't care if the model fits well or poorly. In fact, a poorly fitting model teaches you something about your population in the same way that a good fitting model does. Just because something is statistically significant doesn't mean that that's the only thing you can learn from your data. You can learn things from your data when your variables are not significant, but only if you have a properly designed survey, because that's going to put you in the best position to say it's not significant because it's not significant in the real world. But if it's not significant because you have too much error, because you had a poorly designed survey, now you're in a tough spot. Now you can't say for sure that this actual relationship in the real world is insignificant, because it's entirely possible the insignificance is due to your poorly designed survey. Error creeped into the process too much for you to be able to say anything definitively with your statistics. But don't be fooled by the fact that something is significant and therefore you can actually be confident in making claims, because it's also possible that something is statistically significant and you have error, but that error is biased by being consistently wrong in a certain direction. Rather than being inconsistently wrong and spread all over the board, having too much variance to really see a relationship, that error is all skewed in one particular direction. So what you think you're seeing is not what's really happening, because it's the error that has produced that statistically significant result, not your actual data.
How do you, so this edited response,
Yeah.
I forget the term you use, but people who don't fill in
Imputation.
imputation,
Yeah.
how do you go about doing that without adding a bias, for example?
Well, there's some very, very famous statistical models that look at the different advantages and disadvantages of introducing potential bias by doing a different imputation method. So again, you're weighing the advantages and disadvantages. If you use this particular model, you're likely to introduce these kinds of biases, but minimize those versus a different alternative. And so you're kind of consciously making the choice about which risk is least problematic in terms of introducing error into the model. Or you could just do it in a very simple way. So for example, some people eliminate missing variables by just giving that respondent a random number within the range of possible responses. Because at least that way, considering the fact that it's a randomly assigned number, you're not likely to introduce any bias through the imputation process, but it's also less likely that if you keep doing that often enough, you'll see statistically significant results. So it's a very conservative approach to imputation. All it's likely to do is make it less likely for you to find statistically significant results. It's not likely to bias your data, but that doesn't help you at the end of the day if all you care about is statistical significance. So people do that just to make the models work.
Okay.
And then sometimes they find it's problematic because they don't get significant results.
Yeah, I'm just thinking because, like, for example, I've taken surveys where I just don't know how to answer one of the questions. I leave it blank.
Yeah.
But how do they fill in the question or the answer for me then?
Sometimes they just
Randomly.
drop you as a case
okay.
from that analysis. If there's a missing data point for that particular respondent, you can get just dropped completely from the test. But if you have a small sample size, you have a strong tendency to not want to just drop cases, because every time you do that, your sample size goes down and it's very noticeable. So you can get replaced with a random value, but again, that increases the likelihood of not finding a significant result. You could do something a little bit more sophisticated in thinking about, if you know anything about regression techniques, you can regress the response by knowing something about your other responses and knowing that they correlate with the information that you did not give.
Okay.
And there's other techniques that you'd have to read about because it's too hard to explain very briefly.
Okay, thank you, Mark.
Thank you, Mark. Goodbye, I cannot take your class.